Okay, in this problem, we're going to do a counting problem. So we have a box that contains n balls. These ones are numbered B1, B2, B3, B4 until Bn. Okay? So we're going to do the following experiment. We draw a ball, we record its number, and we put it back. Okay, that means if we start the process and we draw a ball, and let's say its value or its number is 5, so it's gonna be ball 5, we're gonna put it back. Okay, and we draw again and we get maybe some ball 7. Okay, so we do this process twice. So how many possibilities do we have? Okay, so this is a counting problem where we have to use some counting techniques. But for this problem, since it's simple, we can just use our logic to solve it. Okay, so let's start with some simple example. Let's assume that we have just a box that contains two balls, B1 and B2. Okay, so we start our process. We can draw either ball 1 or B2 or ball 2. Okay, we do it again. Before we do it again, if we draw B1, we're gonna have to put it back. If we had drawn B2, we put it back. Okay, now, so this is the first experiment, the first draw, the second draw. After putting back the ball and drawing again, so this is the second step. So we either gonna have B1 or B2. The same thing, we're gonna have B1 or B2. Okay, so how many balls in general? So here we can read the balls that we get. So we can either get B1, 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 B2, B2, B1, B2, B2. So how many ones do we have? We have 4, okay? Or 2 to the power 2, okay? So let's assume that we do this process 3 times. So now after we did the second process, we do it again. So we put back which ball we have drawn and we start the process again, okay? So this is the process in the third time. So here we're gonna get B1 or B2, B1 or B2, B1 or B2, B1 or B2. Okay, so now if we can read from here, so either we're gonna have B1, 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 or B1, B1, B2, or etc. You can read from here. Okay, but if you count all of these, okay, you're gonna see how many? 8, which is 2 to the power 3. Okay, now we start to have some feeling of what we can get. So it's gonna be 2 to the number of balls raised to the number the experiment is repeated. Okay, so let's say if we have n balls or n balls here, okay, and we repeat the process twice, so we're gonna have n squared, okay, based on what we have seen from here. But we can do it in general. Okay, let's say we start. So now we have n balls. Okay, we can draw this one using a tree diagram. So the first step, when we first draw, we're gonna have B1, B2, or Bn. We put the ball that we have drawn, we don't know exactly which one. Okay, it can be any of these, and we start the process again. So if we had drawn B1 in the first step, first process, we may have it again. We may have B2, we may have B3, we may have Bn. The same thing for this one here. Okay, and etc. B1, B2, Bn. Okay, so the first process of choosing the first ball is done in how many ways? In n ways. The second process is done in how many ways? N ways. So we have n times n, which is n squared. Okay? So in general, if we have n balls, okay, numbered from 1 to n, and if we draw the first one and put it back and we draw again, and if we do this process twice, the number of possibilities is n squared. Okay? So this is the starting. We're gonna do more problems like this. More problems are coming, but this is the starting. So this one requires time and thinking and trial and error. To read this one, there is no simple algorithm, but you have to use the techniques and trial and error, and we're gonna learn all the key ideas along the way. Thank you.